Let's say we have two cubes, right? They look identical because they are. All right, but one has a mass of 15 grams, which is the one right here, and one has a mass of 25 grams, which is this one. But again, they're identical in size, meaning they both have a volume of 10 centimeters cubed. So how can we figure out which one do you think is going to have the greater density? Well, let's go ahead and calculate the densities of each of these cubes to know for certain which one has the greater density. So we'll start off by calculating the density of the one with the mass of 15 grams. So again, we go back to that equation, right? Density is equal to mass divided by volume. So in this case, we do 15 grams divided by 10 centimeters cubed. And that would get us with a final density of 1.5 grams per centimeters cubed. Let's look at the next cube. So again, we would do 25 grams divided by 10 centimeters cubed, or mass divided by density, to then find that the density of this cube is 2.5 grams. So look at that, this statement is correct. The one with the greater mass does indeed have the greater density. All right, I want you guys to also remember what we previously learned, and that was that the density of water is 1 gram per milliliter. We're next going to show you another demonstration that will compare the density of clay, candle wax, and water. You're going to watch us compare the densities of these three substances. So before we show you that demonstration, I just kind of want you to look at these molecules and then make a prediction on what's going to happen, how will the wax and the clay behave when they're dropped into the water. So first up we have the wax, and here you can see the molecules of the wax. Wax is made up of carbon and hydrogen atoms that are bonded together in these long chains, similar to what you're seeing here on the screen. Water is made up of oxygen and oxygen and hydrogen atoms, and that's what we're seeing here. And here you can see how these molecules are packed together. And then finally, clay. Clay contains oxygen atoms very much like water, but it also contains atoms such as silicon and aluminum. And here you can see the arrangement of the atoms within clay. So now let's go on, make your predictions as to how will the wax and the clay behave when they're dropped into the water.
All right, so today we're going to be looking at mass. So as you see on the screen, we have an electronic balance. And we're going to see how different size objects, we could predict their mass, and then we could see how they do behave when they're compared to one another. All right, so I have the scale in front of me. And I also have here, this is a wax candle. And you can see, if I hold it up next to a piece of clay, they look as if they have different volumes. By saying that, the candle is larger than the clay. So we can predict, well, if the candle has a larger volume, how would the mass of the candle compare to the mass of the clay? So let's take the mass of the candle, which is larger first. And it reads as 10.8 grams. So the larger candle, meaning the candle that has a larger volume, has a mass of 10.9 grams. Now let's take the mass of the clay, which had a slightly smaller volume, 10.2. So which one was heavier or had a greater mass? 11. So it's a little bit off. All right, so the candle has a higher mass. So then we can make a prediction which one then would be more dense, meaning the amount of material in this given volume, which one would have their molecules closer together. Well, let's see how it behaves in a glass of water. I'm going to use the candle first that has a larger mass. I would think, and then compare it to the clay with a smaller mass. And we could observe that the one with a smaller mass sank, but the candle with the larger mass, larger volume, is floating in the water.
All right, you guys are back. So hopefully you guys noticed, right, that the wax, when it was placed in the water, it wound up floating because they weren't as packed together, especially when you compare it to the water. The water definitely had its molecules more packed closely together, which made it more dense than the wax. Then, of course, we all noticed how the clay sunk right to the bottom, which tells us that those atoms are packed very closely together, which makes clay significantly more dense than water. Great. All right, last question that I want you guys to think about, and that is, how do the densities of different liquids compare to the density of water? So we already determined with Ms. Levin that the density of water is 1 gram per milliliter per milliliter. You already saw with Mrs. Schwartz how the densities of different solids compare with the density of water, right? We saw that with the candle wax and the clay. We noticed how the clay sunk to the bottom of the glass while the candle wax stayed floating, and that let us know right away that the density of the clay was greater than the density of water, but the density of the wax was less than the density of the water. So now let's talk a little bit about this right here. All right. So I'm going to share with you guys just this quick video that I found, and this will help us to figure out the answer to this question. How do the densities of different liquids compare to the density of water? So we have a cup that's being filled with water with some food dye, and now we're going to add some syrup to this cup. Add just a little bit more water, and finally add a nice layer of oil. All right. So what are some things that you're noticing here? Right? Hopefully you notice just kind of the arrangement of these 3 different liquids, right? The syrup is down here at the bottom, the water is in the middle, and the oil's at the top. All right, so what can we say about the density of the syrup compared to the density of the water? Well, the density of the syrup is greater than the density of the water, and that's why it's sunk straight to the bottom. What can we say about the density of the oil compared to the density of the water? Well, the density of the oil is less than the density of the water, and that's why the oil stays at the top. And now let's just discuss a little bit what's happening on a molecular level. So we've already seen water molecules. We know that water molecules are packed closely together, that they're made up of oxygen as well as hydrogen atoms, H2O. And then here, just as comparison, here we have the oil, right? Oil is more dense than alcohol, but it's less dense than water. And we can see here how they are not packed as tightly together as these molecules of water. So that's the reason why we saw the oil settle above the water. All right, and then we can only imagine just how densely packed together the molecules of syrup are for it to sink and stay at the very bottom of the cup.